What's up guys, and in today's video we're going to be looking at how we can solve some harder trigonometric equations, which essentially just applies what we've learnt so far to solving some harder and more advanced equations. So the first one I've got here is 2 cos squared x plus 5 sine x equals 4 for a domain of 0 is less than or equal to x, which is less than or equal to 2 pi. So obviously we're working in radians. Now the first thing I see here is I've got a cos squared x and I've got a sine x. And I want to get these to have both the same, to be both the same. That is cos and cos or sine and sine. Now the thing is, I see here that I've got a cos squared x and the sine isn't squared. So the cos squared x can be substituted. Remember that from the unit circle, sine squared cos squared x, or plus cos squared x will equal to 1. And if you rearrange for cos squared, equals 1 minus sine squared x. So we can make that substitution, and then you see we have sine in both places. So 1 minus sine squared x plus 5 sine x will equal to 4. Now the next thing to do is expand this bracket here. So that becomes 2 minus 2 sine squared x plus 5 sine x will equal to 4. And the next thing I'm going to do is just bring this all over to the right hand side, because I've got a negative 2 sine squared x. Just makes it a bit easier to work with when we move it to the other side. So doing that, we get 0 equals 2 sine squared x minus 5 sine x, and then plus 2. And then if we factorize this, it's just a normal quadratic equation that gives us 2 sine x sine x, and that becomes minus 1 minus 2. So now we just use the null factor law, and we see that 2 sine x minus 1 equals 0, or sine x with minus 2. Let's consider the first case. 2 sine x minus 1 equals 0. If we rearrange for sine x, we get sine x will equal a half. And we know that the related angle for x, sine x equals a half, is, so x related equals pi on 6. And since it's positive, sine can be, since it's positive, sine, the angle is in the first or second quadrant. So therefore, x equals pi on 6 and 5 pi on 6. And if we look at the other possibility, sine x equals negative a half, we know that this is not possible because it's greater than minus 1. And if you remember the unit circle, it's not possible. Next equation is that we're going to have a look at is sec squared x plus 2 tan x equals 0. Now, thing is here, we've got a sec squared and a tan squared, and just a tan on its own. But if you remember the Pythagorean identities, you'll know that the sec squared x is equal to tan squared x plus 1. So we can go ahead and make that substitution. Plus 2 tan x will equal 0. So next thing we do is factorize this. Now that we have 2 tans, we can just factorize this, and as we can see, it's a perfect square. So tan x plus 1 squared will equal to 0. So that means tan of x plus 1 equals 0, and tan x equals to minus 1. Now the related angle for tan of x equals 1 is pi on 4, so we'll write that, x related equals pi on 4. There we are. And we can see that it's -1, so that means x is going to be in the second or fourth quadrant. So therefore x equals pi minus pi on 4 and 2 pi minus pi on 4. So therefore x will equal 3 pi on 4 and 7 pi on 4. In this question, we're asked to find the value of cos 4x given that sine of x equals 1 on 3. Now the first thing I can see is that this is going to involve double angle identity. For cos or sine, not yet known, but because we've got the 4x, I can immediately tell that. Now the first thing I would do here is rearrange or find cos of x using this sine of x. So remember that sine squared x plus cos squared x will equal 1. So therefore 1 on 9 plus cos squared x will equal 1. There we are, will equal 1. And if we rearrange, cos squared x will equal 8 over 9. Now I'm not going to do anything to that, I'm going to leave it as it is. Because as you remember, the double angle identity is equal to cos 2x equals cos squared x minus 1. But as you can see, we've got the cos squared x from this equation up here, and that's equal to 8 ninths. So therefore, cos 2x will equal 2 times 8 on 9 minus 1, which equals 16 on 9 minus 1, which just equals 7 over 9. So now that we know cos 2x, we can now find cos 4x. Using the double angle identity again, we know that cos 4x will equal 2 cos squared 2x minus 1. As you can see, it doesn't necessarily have to be x and 2x. It just has to be a value here, which is then doubled there. So we already know what cos 2x is, and that's 7 on 9. So we 2 times that squared, so 7 on 9 squared minus 1. And if we expand that, we get 2 times 49 on 81 minus 1. And this will equal 98 on 81 minus 1, which simply equals 17 on 81. As you can see, I've just utilized the double angle formula twice, which therefore allowed me to get the final answer. So as you can see, whenever it has like a 4x or a 2x, that immediately gives you the idea that you need to use the double angle formula. I hope this helps by looking through some practice questions.